Alright, so let's look at doing partial derivatives. We are going to, in this video, we're going to look at finding the partial derivative of z with respect to x and the partial of z with respect to y. Now, you also know that, there's different ways you can write it. If you have a function f, okay, of x, y, we can write the partial with respect to x as this and the partial with respect to y as this. Okay, so or you can just write it, you can write it the partial of f with respect to x or the partial of f with respect to y. Either way. Okay, alright, so let's go ahead and get started on this problem. We want to find the partial of z with respect to x. Okay, so all we do is we treat y as a number. Okay, we treat y as a number. So here we're going to take the derivative of 3x squared y cubed. So this would just be the 2 comes down, 3, I'm sorry, the 2 comes down, so 2 times 3 is 6, and then you subtract 1 from the exponent times y cubed. Remember, y cubed is a constant. We're treating y cubed as a constant. It would look like if you wrote it like this. Okay, we're taking the partial of z with respect to x. So everything else in this term here is treated like just a number. So this part here is just a number. So I bring the 2 down and multiply it to 3y cubed. Well, what do you get? You get 6y cubed. And then subtract 1 from the x. So that leaves us with x to the 1. X to the first. Okay? Alright. And then minus, let me change the colors back. And then minus, and then the derivative of 3x is just 3. And then the derivative of 4y, well, there's no x in there. 4y is just a constant. And what's the derivative of a constant? 0. Okay, so our final answer would be this. Alright, now let's take the partial of z with respect to y. Why don't you pause the video and see if you can do it? Okay, alright, so hopefully you tried it and you're going to get it right. If not, let's just look and see what we do. Now we're taking the partial of z with respect to y. So this time x is x is going to be like the constant term and y is the variable. So just like before, see this part here, this 3x squared, that's a number. That's all it is. So I bring the 3 down. 3 times x squared, 3 times x squared is 9x squared. Subtract 1 from the exponent, and that leaves me with y squared. Minus, well, what's the derivative of 3x? Well, 3x is a constant, so the derivative is 0. Okay, so that's 0. Alright, so now let's take the derivative of this last term. Well, what's the derivative of 4y? Well, that's just 4. Okay, so, well, I guess we could work. Let's try getting another one in here. Okay, alright, so here we have one with trig functions. Alright, so I have z is equal to 3y cosine 2x. Alright, so let's take the partial of z with respect to x. Alright, well, this term here, that's just a number. Okay, it would be the same thing as if we had like 5 cosine 2x and we were taking the derivative of that. Okay, the 3y is going to act just like this 5. Alright, so let's take derivative. So 3y is just a constant. And then the derivative of cosine, well, remember what that is? That's negative sine 2x times the derivative of what you're taking the cosine of, so times 2. Okay, remember that's how you take the derivative of trig functions. Okay, so for cosine it's negative sine and then times the derivative of what you're taking the cosine of. All right, and so now I get, let's see, that's going to be negative 6y sine 2x, and that would be our answer. All right, let's take the partial of z with respect to y. Okay, the partial of z with respect to y. This time, y is our variable, and everything else is a constant term. Okay, so let me just take this and rewrite it so maybe you can see it better. So cosine 2, let me write it up here. Z is 3 cosine 2x times y. Okay, all I did is I just put the cosine 2x between the 3 and the y. Okay, because look, that's just a constant. So let me ask you this. Let's say if we had 5x, I'm sorry, let's say we had 5y. What would be the derivative of 5y? The partial with respect to y. Well, it would just be 5. Okay, well, that's all this is. That is just like that 5 there. So the derivative is just 3 cosine 2x. And that would be your solution. Okay. All right, so I think I'm going to stop it here. I've got more examples I'm going to do. You might want to check those out. They're going to get tougher as we go. So I'm going to have some with e to a power, some more trig functions, logarithmic functions, and all that good stuff. All right, so hopefully this helped. Don't forget to like and subscribe. Check out my other videos. All right, thanks.